So I want to talk about a system of equations. And what that means is just that two equations are graphed onto one coordinate plane. The point where those two equations, where those two lines intersect, is your system of equation. So let's just go ahead and jump right into it. I'm going to graph one equation in red and one equation in green. Here we have y equals negative 3x plus 4. So it is in slope intercept form. Sometimes you will be given equations that are in standard form that you have to convert into slope intercept form in order to graph. You cannot graph an equation unless it is in slope intercept form. So I'm looking at y equals negative 3x plus 4. My y-intercept is 4. I find 4 on the y-axis. I plot a point there. My slope is negative 3. I want it as a fraction so that I have a rise or a fall over run. Since it's negative, I have a fall. So I go back to my y-intercept and I fall 3. 1, 2, 3, and run 1 to the right and plot another point there. I fall 3 again, 1, 2, 3, run to the right again. You only need 2 points in order to graph a line. I like to have at least 3. So once I have at least 2, but I like 3, I can go ahead and plot or graph my line. So this line represents the equation y equals negative 3x plus 4. Let's now take a look at our other equation, y equals 3x minus 2. My y-intercept is minus 2. On the y-axis, find minus 2, plot a point there. My slope is 3, but I'm going to put it over 1 so that I have a rise over a run. Because it's positive, we're going to rise 3. 1, 2, 3, run 1. Plot a point there. Up 3, rise 3. 1, 2, 3, run 1. There are my 3 points. I can go ahead and graph it. And there are my 2 lines for each of my equations. And I see that they intersect at one point. They intersect at this point here. Remember, when you give the coordinates of a point or a location of a point, your x value comes first and then your y value. Those are your xy coordinates. So along my x value, we have 1. But where this point lines up with the y value is also at positive 1. So this is my system of equation, 0.11, because that's where the 2 lines intersect. Let's take a look at another example. For number 2, I have y equals x plus 2. And I also have x is equal to negative 3. So the first one is in slope intercept form. I'm going to find 2 and plot a point there since that's my y-intercept. My slope, you don't see a number in front of the x. There's always an imaginary 1 there. So that means that my slope is 1, but I like to write it as a fraction. 1 over 1. So that again, I have a rise over a run because I can grow my line from my y-intercept using my slope. So rise 1, run 1 to the right. We always run to the right. Rise 1, run 1 to the right. Rise 1, run 1 to the right. And I can go ahead and graph my line. Now here, I have x is equal to -3. It is not in slope-intercept form. But what I can do is along the x-axis, find -3, plot a point there. I can find a point anywhere else. I could plot a point anywhere else where x is equal to -3, because again, we need 2 points in order to graph a line. So where x is equal to -3, it's along this line here. So I could plot one down low, I could plot one up top. It doesn't matter as long as the x value is -3. Here, we have x is equal to -3, but y is equal to 0. Here we have x is equal to -3, but y is equal to -4. It doesn't matter as long as my x is equal to -3. Once you have 2 points, go ahead and you graph. There are my 2 lines. They intersect here. And whatever the coordinates are for that point, that is my system of equation. So here we go. We start at the origin. We count over on the x-axis first. 1, 2, -3. So my x value is -3. And then along my y-axis, we drop down to -1 on the y. So this -3, -1 is my system of equation. Really hope this helps.